Section 3.3 is on graphing systems of linear inequalities. These get pretty fun and intense because we get to a point where there are quite a few inequalities that we need to graph onto one graph. So it gets a little crazy. So you may want to get out some colored pencils. Otherwise, I will show you a method that kind of makes it a little bit easier to see where this shaded region would be as well. Let's start out with just a system of two inequalities. We're going to graph both of these inequalities, and if you remember, when you graph inequalities, you need to shade one side of the line. Let's start with 2x minus y is less than or equal to 3. If I'm going to graph that, the first thing I need to do is get that one solved for y. So I'm going to subtract 2x from both sides. So I've got negative y is less than or equal to negative 2x plus 3. And then from there, we divide by negative 1. We do that to everything. Okay, so the negative 1's over here factor out, and we get y. Remember, when you divide by a negative, you also have to flip the inequality symbol. So that becomes greater than or equal to, and then it's going to be 2x minus 3. When I graph this line, first we start with the y-intercept. That's negative 3, so I'm going to go to negative 3 on the y-axis and put a dot. My slope is 2, so I'm going to go from this point up 2, right 1. I'll do that a couple times, at least. Okay. And then we need to draw in a line. And remember, for this one, we're actually going to want to have a solid line because of this equal sign. So I'm going to start with a solid line through those points. That's not a perfect line. I'm going to fix that just a little bit. Okay. And then we need to decide which side to shade. The easiest thing to do is plug in the point 0, 0. So if I go back, I always go back to the original. If I plug 0, 0 in for x and y, I'm on the left side of the inequality, I'm going to have 0, and then it's less than or equal to 3. And remember, I always go back to the original when I plug in, because down here, sometimes you may make a little error, like you may have forgotten to flip the symbol or that kind of thing. So when we go back to the original, we don't have to worry about those little minor mistakes that we may have made. Ask yourself, is 0 less than or equal to 3? Yes, it is. So that means that this line is going to be shaded towards the 0, 0. Because I'm going to try to find where the shading meets, for right now, I'm just going to draw some arrows showing me that my shaded region is going that direction, okay? Normally we would shade this whole side in, but for right now, I'm just going to draw arrows, okay? Because if we do too much shading, sometimes it just gets a little bit crazy and it's hard to read where everything meets. So arrows sometimes work out very nice and handy. Okay, let's move over to the second inequality. I'm going to subtract x from both sides. So that leaves me with 2y is less than negative x plus 4. Divide everything by 2. Okay, so y is less than, that's going to become negative 1/2 x, and then plus 4 over 2 would be plus 2. So we start with the y-intercept. We put a dot at 2 on the y-axis. And then the slope is negative 1/2, so I'm going to go down 1, right 2. Down 1, right 2 again. And you can do that as many times as you feel necessary. And this time, we need a dashed line because there's no equal sign. So I'm going to put a dashed line through those points. Okay? And then again, we need to decide which side are we going to shade this on. Plug in 0, 0. So I'm going to go back to my inequality here. If I plug 0, 0 in, on the left side I'm going to have 0. And then we have less than 4. Is 0 less than 4? Yes, it is. Okay, so this is the line we're looking at right now. 0, 0 works, so I need to shade in that direction. Okay, now if you had colored pencils, you could do the shading, and if you had colored pencils, you'd have shading over here on this side for the first point, and then you'd have shading all the way down here for the second line. And now if you look at where they meet, I just like to follow these arrows. This line's going this direction, this line we're going down, so where they're meeting is right in this area right here. So that's where I'm going to put my final shading. Okay? So I'm not going to be actually going through this entire problem with you, but I wanted you to see what it looked like in the end. So you could work it out and you'd have a good example to look at to see where the shaded regions would meet. Okay? So again, this is in your notes, but I am not going to work through it on the video. We're going to move on to the last problem in your notes with 5 inequalities. Let's start with 2x plus 3y is greater than or equal to 6. First, I would subtract 2x from both sides. That leaves me with 3y is greater than or equal to negative 2x plus 6. Okay, divide everything by 3. So that leaves me with y is greater than or equal to negative 2/3 x plus 2. Go over to graph it. We start at 2 on the y-axis, put a dot, down 2, write 3, down 2, write 3. And this is going to be a solid line because there's an equal sign. So if you give me a second, I'm going to get a solid line in here. I want it to be green. Okay. All right. Oh, that didn't really go green, but that's all right. We're going to work with it. Okay, so there's my line. Now we decide which side to shade. Again, plug in 0, 0. So if I go back to the original, I'd end up with 0 is greater than or equal to 6. Is 0 greater than or equal to 6? No. So we can't shade towards 0, 0. We'd have to shade above this line. Okay, so I draw in my arrows. Move over to the next one. First thing I would do is subtract 4x. That leaves me with y is less than or equal to negative 4x plus 4. Start at 4 on the y-axis. And then for the slope of negative 4, I'd go down 4, right 1. Do that another time. Okay. And again, we have a solid line. So I'm going to put a solid line through here. All right. Go back, plug in 0, 0. When I do that, I'd have 0 is less than or equal to 4. Is that true? Yes. So for this line, we have to go toward the 0, 0. So if you look real closely, right now we're just in this shaded region right here, okay, because that's where the arrows would be meeting. Now we'll do one more crazy inequality. We're going to subtract x from both sides. So I'd end up with 5y is less than or equal to negative x plus 25. Divide everything by 5. So y is less than or equal to, that becomes negative 1/5 x plus 25 divided by 5 is 5. So I start at 5 on the y-axis. We're going to go down 1, right 5. Do that a couple times. And again, we have a solid line. So I'm going to put a solid line through those points. All right. Then we decide which side to shade. Plug in 0, 0. This side would be 0 is less than or equal to 25. Is that true? Yes. So I look at this line. That's going to go this direction towards the 0, 0 because 0, 0 works. Now if you look real closely, right now I'm just in this triangular section right here. Just that tiny little triangle. Okay, now I have two more equations to graph, or inequalities, excuse me, not equations. First we start with x equals 0. Okay, x is greater than or equal to 0. I'm going to make this kind of bold. It's going to be crazy. X equals 0 is a vertical line. So I'm going to draw my, I should not have used, we're going to go back and I'm not going to use that bold line because that's going to get kind of crazy. So we're just going to go back to original line here. Okay. Oops. Here is where x is 0, okay, on that vertical line. Now think to yourself, when does x get bigger? X actually gets bigger to the right, okay? So I'm thinking just a little bit in this direction. So right now, I'm in this very tiny triangle right here. That's the only place we're meeting right now because this vertical line here goes to the right. Now let's graph y is greater than or equal to 0. Okay, that's going to be a solid line because it's equal to horizontal through the x-axis. So that's this line here. When does y get bigger? Y gets bigger above. So this is going to be going upward. Okay. But if you look at where all of these lines and shadings are going to meet, it's still going to be just in this small triangle right in here. Okay, so that would be my final shaded region. Like I said, these linear inequalities systems, man, they get pretty crazy. You've got to really pay attention as you graph these and make sure that you're finding out where all the shading meets every time you draw in a new line. And that concludes section 3.3.